Hello dear student, this is Professor Ashok Kumar and I work in Department of Mechanical Engineering at Dr. Subhash Technical Campus. So this is my first video lecture on subject kinematics and theory of machine. It is a very much important subject as far as concern of the mechanical and mechanism studies, link analysis, and of course machine analysis and force analysis, as well as velocity, acceleration and displacement analysis. This is subject plays a crucial role for the designing of any kind of mechanism and machinery. So this is the chapter number 1 that we are going to start, and that is an introduction of mechanism and machines. Basically, entire subject contains very much important chapters. That means, first of all, you will be given an introduction about mechanism and machines. Then after synthesis and we can say that the analysis of mechanism will become in chapter number 2. Chapter number 3 will cover gears, its type, gear trains and its analysis. Chapter number 4 will be covered cams and followers. That means if you are using cam and follower mechanism, then what will be the velocity and acceleration values and its profile for each and every point one links. Then after we are also discussing on the mechanism analysis, and of course at the end we will discuss on the machine element. So this is what this is about somewhat we can say that the highlight of entire subject, and this video lecture especially in which we will discuss chapter number 1, introduction of mechanisms and machines. Because of a little bit large portion that is given inside this chapter, so I have divided the entire chapter in 3 parts. Part 1, part 2 and part 3. This is specially the part 1 in which we will discuss basics of links, its types, basics about the machines and various types of mechanisms that we will discuss within these lectures. Of course, we should to start with an introduction. We will discuss an introduction specially on machine and its types of analysis. If we are talking about machine, then we can define that a machine is a device which receives the kind of energy form in some suitable way, and it convert the energy that has been received by it to some particular type of work. So this is generally known as a machine. Suppose you have any machine and which consumes, or we can say that it receives some form of energy, and it converts this received energy in terms of some specific output. It will be known as a machine. For example, if we are taking an example of lathe machine or shaper machine or even milling machine, which are widely being used and also available in workshop. So what happen in case of such a machinery? It will receive an electric energy from electric motors, and through its mechanism which is mounted inside that particular machinery, it will give us output motion of tool post. So we can say that all that machinery is generally converting one form of energy to another form of energy, and that's why we know it all such machinery as a machine. Of course, along with lathe, drill, planer, shaper, all are known as we can say that kind of machines. One more example I would like to introduce along with lathe machine is the heat engine. A heat engine, that means what we are using engines in our automotive vehicle, that will be known as a heat engine. Basically, it is also a kind of machine in which specially the heat energy, the form of heat energy by ignition of fuel, which received by cylinder and piston assembly, and it will be converted to useful mechanical work of the crankshaft. So we can say that in case of heat engine, it perform look like conversion of a form of energy of heat energy into mechanical work. So of course heat engine will also, we can say that it is the kind of machine. Similarly, you can take the numbers for example like steam turbine, pump, gas turbine, and numbers of. So all that machineries are, or all that devices are generally known to be machines. Now as we know that in order to convert the energy, one form of energy to another, we require some mechanism. And for that, we know that mechanism is made of the assembling of numbers of links. So each and every links which are connected with each other, and ultimately it forms mechanism, and which is the heart of any machine, which convert the one form of energy to required form of energy at the end. Now, if you require to study and analyze this machine or even mechanism, then there are two basic ways. One is machine analysis, and one is we can say that the synthesis or synthesis of mechanism. If we are talking about the machine analysis, then machine analysis itself means to study and focus upon motion and forces which are produced or which arise during the conversion of one form of energy to another form of energy. For example, if we are taking 4-bar chain mechanism, if we are taking slider chain mechanism, or any kind of mechanism, so while it transmits the motion and power from one link to other link or end link, so what will be the magnitude and direction of the velocity or acceleration or even displacement, or even I say the angular displacement, all that study that you are doing that will become under the machine analysis. So in order to calculate the magnitude and direction of all the points which are located on links, or even especially you willing to calculate the magnitude and direction of particular links, so it will be divided further in kinematics and dynamics. So we can say that for the machine analysis, kinematics and dynamic studies are the requirement for the machine, or we can say that the mechanism analysis. Similarly, if we are talking about the synthesis or the synthesis of mechanism, generally then it includes the design of various parts of machine which concerning its shape and size or material. So in order to synthesize any mechanism, the entire synthesis activity or procedure focus primarily on the shape and size of the link, material selection, its assembly with each other. All that study will come under the synthesis. So synthesis primarily focus upon the which shape and the size of the particular machine link or the mechanism link should be selected, what should be the material in order to sustain the external load or the vibration, and how we can have the proper arrangement of each and every links so that the effective mechanism can be possible. So all that studies will come in synthesis analysis. So it is clear by the machine analysis and synthesis that the entire subject include the studies of relative motion between various links, various forces that are going to be acting on the links or the mechanism that we will discuss later on. Now if we look at this entire subject, then entire subject is divided in primarily two branches, kinematics and dynamics. Kinematics and dynamics. Basically, kinematics is related to study of relative motion between the parts of machine. That means it is the study of position, study of displacement, study of rotational speed, velocity and acceleration. Whereas dynamics of the machinery itself include the statics and kinetics. Generally, it primarily focus upon the various forces acting on various parts of the machines. So if we are taking static dynamic analysis, then the static portion of dynamic analysis is related with forces which act on part of the machine, which may be assumed without the mass. And if you are taking inertia forces of any part or the body or even link, and you are doing force analysis, of course it will be known as a kinetics. Look at the bottom figure you have given. Basically it is a slider crank mechanism, and through this mechanism we are operating cylinder and piston assembly. So in this engine, piston is made to reciprocate in the cylinder due to applied external steam pressure on the piston. So the reciprocating motion of the piston is herein required to convert into rotary motion of the link shaft by using connecting rod or crank. So if you are taking kinematic study of this entire mechanism, that means slider crank mechanism, then the relative motion of various parts can be determined by using kinematics, and which gives us the velocity, or we can say that the motion characteristic of each and every link which are assembled in slider crank mechanism. Similarly, you are doing dynamic study, and especially in dynamic you are doing static analysis, then the engine can be treated as a framework, because in case of statics we are not concerning or concentrating on the mass, we are just determining forces, and without mass of the link we are calculating or determining forces. So if you are doing static analysis, of course you have to ignore the mass. Force acting on the piston at various positions can be determined if the pressure and area of the piston is known. Secondly, the steam force produce thrust force in the connecting rod, and by the resolution of forces we can determine various forces that can be act on various links, either on crank, either on connecting rod, either on piston. So this includes the dynamics analysis, especially static analysis. Now similarly, if you are carrying out kinetic analysis, of course now in case of without mass considering, you have to focus upon mass, and if you are considering mass of each and every link including piston, connecting rod, crank, of course if there is mass, definitely there will be inertia force. So in case of kinetics, inertia force is the prime condition for the kinetic analysis in dynamics. Now point number 2 that we are going to discuss, that is kinematic link, or even say the element. Generally each part of machine which has relative motion to some other part of the machine is generally treated as a kinematic link, or we can say that an element. A link is not necessary to have a rigid body, but it should be resist something external forces and velocity. So we can say that a resistance body is one which is capable of transmitting the required motion and forces with or we can say that with little bit deformation. So herein, if you are looking any mechanism, and especially you are focusing upon any particular link, we can say that that link will be the kinematic link if it transmits motion, or we can say that the torque, then we can say that it will be the kinematic link. Now kinematic link can be classified in basically 3 categories. One is a rigid link, other is flexible, and last is the fluid link. If we are talking about rigid link, then it is the links which do not undergo an appreciable deformation whenever it is transmitting motion and power. So rigid itself resistance to external deformation. So if you are finding any link in mechanism, and whenever it transmits the motion and power and it has not any kind of deformation, of course it will be known as a rigid link. Generally crank, connecting rod, piston, we can say that the some bearings are the few common example of rigid links. And rigid links have we can say that the 3 types for the binary link, ternary link, and quaternary links. After that, the second types of kinematic link is a flexible link. Look at the title, flexible link. So it gives mean directly that whenever you are transmitting motion and power, of course there will be a little bit deformation. And look at the right hand side diagram, there is one belt drive. So belt works herein as a kind of flexible link, because whenever you are transmitting power from driving pulley to driven pulley, of course belt will expand as well as contract. So we can say that there is a little bit deformation in lengthwise, and this link is subjected with elongation and contraction. So generally if you are finding such links which have the deformation little bit while transmitting motion and power, of course that will be none other than the flexible link. Generally chains or belts, springs, rubbers or rubber links, we can say that such type of the links is known as a flexible link. Then after third types of the link that we are going to discuss, that is a fluid link, and generally the links which transmit the motion by virtue of fluid pressure is known as a fluid links. For example, we are using hydraulic brake, we are using hydraulic lift, we are using hydraulic check. So all that devices, ultimately we are applying action by virtue of pressure of hydraulic fluid, we are using it. So this is somewhat known as the fluid link, especially the link which utilize the pressure energy of the fluid is known as a fluid link. Now it's time to discuss a structure, and basically if you require to define the structure, then generally it is an assembly of a resistance body. Generally this term structure we use especially for the we can say that the truss work or roof work or constructional building material. For that we are using word structure. So if you are observing the structure of building or structure of any roof, or we can say that the machinery, it clearly means that it has the rigid construction. So it gives us idea that whenever any external forces or we can say that external loading is applied over that various links of that structure, it will not deform, and in that way it will resist the external force applied by the various forces, or we can say that the various regions. So roof machine, roof trusses, machine frames, even building construction structure, we can say that this is the structure. And if we are comparing structure with machine, then structure has no relative motion. That means each and every link of structure which is assembled to form a structure having no any kind of relative motion. Whereas if you have the machine or the mechanism, so each and every link of that particular machine or mechanism having the relative motion between that. In case of structure, it only transmit especially dead weight or forces, but in machine component or the mechanism of machine, it transmit both forces as well as motion, because if you are rotating one link of a mechanism of machine, of course other remaining links have the relative velocity with each other. So we can say that along with forces, motion is also being transmitted if you are using mechanism or machine. Structure example is very common, like roof trusses, machine frames, as I said, constructional buildings, all that are come for the structural example. And if you are talking about the IC engine, or we can say that other machinery like lathe machines or the mechanism of workshop machinery, all are known as machines. Now point number 4, that is the constraint motion, and this especially topic in which we will discuss which type of motion is given to each and every link of mechanism. So there are basically 3 types of motion that should be given to each and every link. Number 1 is completely constrained motion, second is incompletely constrained motion, and third one is successfully constrained motion. So starting with the completely constrained motion, generally it is the motion in which the relative motion between the 2 links can be placed only in a definite direction, and it can be predicted. Suppose you have the assembly of 2 links, say a slotted box in which a square bar is inserted, and you are pushing that square bar in slotted box, or we can say that the slotted body, then it is only possible for the slotted bar to move in only one direction. That means if you are taking this diagram and observing clearly, then there is a box in which we can say that the square slot is cut away, and in which that particular square slot there is a square bar is inserted. If you are pushing it or even pulling it, what happens? There is only one chance for the square bar to move either in forward or backward direction. So if you are finding any assembly of linkages in which especially there is only one specific direction in which a motion can be possible, that will be known as a completely constrained motion. For example, bar sliding in a rectangular slot, for example you are giving any external force on body to move in a very specific direction. So all that example will become for the completely constrained motion. Now after that, second types of the motion, that is incompletely constrained motion. When two links are connected in such a manner that their relative motion can take place in more than one direction, of course it will be known as incompletely constrained motion. Now just you have to replace the square bar that has been inserted in case of completely constrained motion. Now insert a circular shaft in circular hole of the same box. Now if you are revolving this circular bar or pushing the circular bar, you can see that there are two kind of motion can be possible. One is rotational motion of the circular bar, another is sliding motion. So over here in this assembly we can say that the circular bar has the motion in two direction. One is plane parallel to the shaft plane, another is perpendicular direction through which you are getting the movement of the circular bar. So if you are finding any assembly in which specially this kind of the parts in which specially two velocity in different direction are getting, of course it will be known as a incompletely constrained motion. For example, we can say that if you are screwing nut in bolt, it will be the very simple example of incompletely constrained motion. After that, third type of the constrained motion, that is the successfully constrained motion. So this type of motion can be identified whenever the relative motion between the links is not completely constrained but by itself, but it is made so by some other means. It is called a successfully constrained motion. For example, if you are using key on the slot of outer periphery of shaft, of course due to insertion of key on shaft, it will restrict to move the shaft and pulley in axial direction. So we can say that in order to constrain the motion here in shaft and gear itself not play any kind of role, but by adding the third element like key, the constrained motion can be possible. So this is what about the types of constrained motion that we have discussed. Now point number 5, that is kinematic pair. And generally when two kinematic links are connected in such a way that their motion is either completely or successfully constrained, then these two links are generally known to be a kinematic pair. For example, the piston and cylinder of the steam engine will form a kinematic pair because they are in contact and the piston moves relative to the cylinder. So this is very common example of kinematic pair. The condition for the kinematic pair to be generated is the kinematic links must be joined in such a way that the motion that is resulted by assembling of various links should be completely or successfully constrained. Then and then the kinematic pair can be have the possibility of kinematic pair. Now kinematic pair can be classified based on three criteria. First criteria is you can classify any kinematic pair according to the nature of relative motion between the links. So if you are classifying based on nature of relative motion between the various links, the first and most important types of the kinematic pair, that is sliding pair or say prismatic sliding pair. Generally a sliding pair is formed by two links in such a way that one link is constrained to have the sliding motion relative to the other link. You have given the figure, look at the right hand side, there is a one block in which especially square slotted hole is provided in it, and special shape or say the square shape of sliding bar is inserted in it. So whenever you are pushing that bar, the relation of motion between block and that bar will be only of sliding type. So we can say that this is the pure example of sliding pair or prismatic sliding pair. Other similar example you can also take for the piston and cylinder assembly, because we know that in case of piston and cylinder assembly, piston slides relative to the fixed cylinder. After that there is a turning or a revolute pair. When two links are so connected that one link is constrained to turn, or we can say that rotate relative to the other link, they are said to form a turning pair. It is also known as a hinge pair too. For example, if you are taking lathe spindle which is supported in headstock, we know that the spindle will move or spindle will rotate revolving with respect to fixed position of head. So this is very simple example of turning or revolute pair. A few other example if we are taking, then we can say that the crankshaft which is rotating in crank bearing, of course the road wheel of, we can say that the wheel of an automobile, all that examples are generally formed as a turning or revolute pair. After that, a third type of the classification of kinematic pair is a screw or helical pair. When the nature of contact between the pair of each and every link is such a way that one of the link can turn about the other link by screw thread effect, it will be known as a screw pair. For example, if you are taking a nut and a bolt assembly, whenever you tightening bolt in nut, what happens due to thread presence there, of course the bolt will move, or either nut will also move along with sliding action. So this is the typical example in which especially motion of one link will be possible with respect to other link by virtue of screw thread. Fourth type of the link, that is the rolling pair. When two links are connected in such a way that one of the links rolls over the other links, then we can say that it is a rolling pair. For example, if you are taking a roller ball bearing in which specially roll will rotating with respect to outer and inner say face, or outer and inner race, in that manner you can have the rolling pair. If you are taking a journal bearing example, it's very common to understand the rolling pair. Fifth type of the pair, kinematic pair, that is spherical, or we can say that globular pair. Globular pair basically in which specially one link forms a spherical shape with respect to other. If you are finding any assembly in which specially one link has the spherical contact with respect to the meshing link, of course it will be known as a spherical or say globular pair. For example, if you are taking a gear shifter of your car, or say the trunk or bus, in which especially gear shifter can be moved with respect to a fulcrum which is fixed. So if you are observing that a gear shifter, then it can have the spherical contact with that particular fixed point, or say the fixed block. So this is what about the spherical or globular pair. And of course you can also have the classification based on the nature of contact between the links. There are classified on the two main category, lower pair and higher pair. Generally, when two links have the surface contact, or we say the area contact, whenever it transmits the motion and power, they will be known as a lower pair. In order to form a lower pair, the contact area should be of the area contact. That is the primary condition in order to form a lower pair. For example, if you are taking piston and cylinder assembly, or shaft which is rotating inside the bearing, then we can say that there is not any kind of the point contact, but there will be a common surface, or we can say that the surface or even area contact between two mating links or parts. So in all such example you find the lower pair, and in case of that lower pair, the relative motion is purely sliding or turning, because we know that in case of a shaft in bearing example, shaft is rotating relative with bearing, whereas in case of IC engine assembly, that means piston and cylinder assembly, piston is going to be slide with respect to the cylinder. So this is what about the lower pair. If you are talking about the higher pair, then when the two links are connected in such a manner that they have a line or even point contact, whenever it transmits the motion and power, that will be known as a higher pair. For example, if you are taking cam and follower, then we know that the follower end has a knife contact. So whenever cam is rotating and follower follows the contour of cam at that time, there will be a point contact area between outer peripheral surface of cam and end point of that particular follower. So the prime condition to form a higher pair is to have the point contact between two mating surfaces. This is what about the higher pair. And last classification of kinematic pair can be possible on the according to the mechanical arrangement. That means how you arrange all the links mechanically. Based on that, you can have the classification. First one is the closed pair or self-closed pair, especially in such type of kinematic pair, closed pair or self-closed pair, all the links of pair are held mechanically, and generally all the lower pairs are generally known as a closed pair. So mechanically, if any links are connected with each other, of course it will form like a closed pair. And secondly, forced closed pair or unclosed pair or even open pair is the pair in which links are not rigidly held with each other. That means there will be no any kind of mechanical joining or bonding with each and every link. If you are taking example of cam and follower, you can see that there is not any kind of mechanical linkage between cam and follower. So this was the few introduction about the chapter number 1, introduction of machine and mechanism, entire lecture in which especially we have discussed upon machine and mechanism. Then we have discussed a lot about the various kind of links, different types of the kinematic pairs, and we have discussed a lot especially based on various links that are widely used for the motion and power transmission. Thank you very much for your attendance to this video lecture. Thank you very much.